stomp on free speech like this in a forum like YouTube, it's not
antagonizing the beast.
Yeah, you awaken the giant, the sleeping giant.
A wet towel at a lion.
Well, the sleeping lion.
Yes,
the sleeping and hungry lion.
Well, once you understand that, then now you have a good tool to get your message across by making it such that somebody will ban it, and then suddenly everybody gets your message.
Yeah, you can't stop these people because they have nothing to say, and they see this as a valid way of basically stopping any dissenting opinion.
But I think if they were, yeah, go on.
No, sorry, go ahead. I was pretty much finished.
If they had, if you like, the next time this happens, if they find this video summarizing this incident that you've just described, and things like the Venom Fang X video, I think that's a fairly powerful deterrent. I mean, the Venom Fang X thing never really got the videos that the DMCA never got mirrored, and in that sense, I think what you've just got here is set an important precedent in that if you can show that, okay, yeah, it's an important precedent that if you were to sort of, if you're doing this just to silence something that you don't like, it's really going to bite you in the ass. So.
Yeah, and definitely if you do it without consulting any legal advice, and there's going to be a moment which I wish I could be there when it happens, when he's going to get all these counter notices that have now been filed, and he's going to consult someone who understands what's going on, and that person's going to turn around and say, actually, you shouldn't have done that, because they know that.
To do it once, you can sort of say, well, you know, I was confused or didn't have a good understanding of the law. When you're into doing it, when you're into a pattern of behaviour, this is the sort of thing that that can land you in problems with criminal law. So there's the civil law and the criminal law, and if you're systematically abusing the system, the DMCA like this, then eventually the criminal law will spark into action. In that, if it doesn't, then there is no point in having the law. That if you're not going to whack the people who systematically abuse the system, then the law simply has no meaning. So that would be a real whack on the head, in that when you file the DMCAs, you agreed jurisdiction of whatever it is, YouTube, San Bruno in California. So he would be doing this internationally, and against it would be US government versus whatever his name was.
I'm not 100% sure where this is true, but I think it is. In Fiji, there are no copyright laws at all. Remember that? There are no copyright laws.
I don't remember.
I was almost sure that was.
It doesn't make any difference.
Population of Fiji, 20,000.
It doesn't make any difference. There's no bloody books there anyway.
Well,
They don't need to be when they have an island paradise.
yeah. Everybody sleep out there eating. Actually, they were. Everybody in the hotel.
We were reading about Canada and what wonderful hard winters it has.
Yes. The thing is, everybody would come to the little hotel, sit down in the foyer, and read a book. And you're thinking, what are you doing here? This is all you're going to be doing. The people do that for days on end. It's like, go outside, go to the beach, for Christ's sake. Look how freaking rude. You could have done this in a sauna at home somewhere, you know.
Yeah. If you've got a good imagination, comfort that you're in an armchair.
Yeah.
Anyway, guys, I just wanted to drop by on BlogTV and just give people a little update about that, and say thanks to everyone who is involved. So thank you very much, guys. And but I'm gonna. Oh yeah, you got
We were having a discussion earlier whilst Mr. Pretentious is burying his nose in the brush. Judging distances to the galaxies.
Yeah.
I know, as far as there are several methods of doing it. I know of 2 methods. One is to Seaford variables, supernovas, and from that you sort of calibrate the redshift, yeah? What are some of the other methods that you can use to judge distances to galaxies?
So supernovas is probably, with regard to very, very high redshift galaxies, supernovas are quite important now. With regard to other methods for judging distances to galaxies, I mean, there's nothing really particularly useful. One of the big problems with judging distances to galaxies is how we relate things like the redshift, which we calibrate from those two methods, how we relate it to the distance. Whenever you look in, say, you go on the news and you see a news story about some new object, the furthest object that's ever been found or whatever, and they give you the distance in billions of light years, and there's a big problem with the media actually giving the distance. It's not always comfortable to give the distance to galaxies. It's fair enough to say things with like M31 and M33 that they're, you know, roughly within 3 million light years away. But this idea of distance is not really very well, it's not well discussed in the news. It's sort of stated as, well, we know it's this far away, or, you know, they give it the distance in terms of light time, or they give it the distance in terms of the actual distance that it is now based on Einstein de Sitter expansion and so on. But what they don't give you is the redshift quite often. And actually, the distance to these objects will probably change in the future as our understanding changes, but the redshift is something we can know very accurately. So in the future, it'd be nice to think that, you know, we stop sort of stating the distances to things, because I think this will actually change in the future.
Yeah. Also, I was kind of curious. Do you know actually the technical... How do you measure the spectrum of a galaxy? How do you get the redshift of a galaxy? Because it's a fuzzy object.
Yeah, it's a fuzzy object. So you measure the spectrum of the light coming from the galaxy, and then you measure it against what you can do is there are several ways you can do it. You can do it through the atmosphere of a planet. That's quite a rare way of doing it. Or you can do it by calculating the addition to the light from other stars, foreground stars, and then you can test it against a local source on Earth. So you're measuring basically the amount of light that is, how can I put this? You're measuring basically the amount of light from the galaxy which is added to the light from foreground stars or subtracted through the atmosphere of another planet or through the atmosphere of our planet versus, say, a space-based observation. And then you are comparing it with, you're doing your Doppler comparison by taking a light source on Earth. It's not so simple as, say, measuring the spectral absorption. The only way you can do that is to know roughly the kind of absorption you get from rough types of galaxies. And this is why we have a galaxy zoo, where we try to find out roughly what kind of spectrum we can expect from a spiral galaxy, roughly what kind we can expect from an elliptical galaxy, and then based on what we observe, we kind of extrapolate that result, and that's why it's very difficult to discover new types of galaxies. But yeah, basically we look at the light, and there are various ways you can do it. You can do it by addition or by subtraction from other sources, or you can simply take the light and base it against a known quantity from a nearby galaxy, where you know roughly what the quantity of stars are. So you're looking at, for example, basically the spectrum will allow you to see how many young stars versus old stars there are, and you know that in a spiral galaxy, you know you expect to see young stars near the edge and old stars in the center, and then old stars in the halo. In an elliptical galaxy, you know you expect to see roughly all old stars roughly the same age. So that is how you would do it. You would take a known quantity where you can measure a galaxy that you know roughly what the composition of stars are, because you can study the galaxy in some detail, and then you kind of compare that with what you believe you're looking at, whether it be a spiral galaxy or an elliptical galaxy. And of course, when you go back far enough, spiral galaxies don't really exist in the young universe, so then you kind of know you're looking at elliptical galaxies.
I mean, I guess I was more after a sort of practical end, as in what's the thing that goes on the end of this telescope? If you get a sort of fuzz patch like this, which is your galaxy, you've got to get it down to a line to actually get a spectrum of it. Yeah. I mean, how do you actually get a spectrum of a fuzzy object?
How do you get a spectrum of a fuzzy object? That I don't do, because that is a type of observational astronomy that I don't do. But the way that they do it, I believe, is simply by, they study the brightness curve of the object, and then they just find the maximum brightness, so that what they know is basically where the core of the object is. Because you do get a fuzzy object, but it also falls off in brightness quite considerably very quickly. It looks fuzzy, and it looks it looks like it might have a sort of average brightness throughout, but actually, when you look at the data, the brightness does fall off very quickly, even though the picture looks a bit sort of overexposed and looks a bit bloomed out.
I'm sorry, DP, I thought I'd given you your hat back. I'm sorry.